Taiwan Sugar Corporation, TSC, is a time-honored state-owned enterprise and the leading brand of sugar production and marketing in Taiwan. With 7 major business divisions, TSC has diversified its operation, gradually transforming itself from a traditional agricultural processing business to a multidimensional entity covering agriculture, industry, commerce, and services. The Sugar Business Division focuses on sugarcane cultivation and sugar production. Golden sugar is one of its major products. The golden sugar is made from quality sugar canes. Sugar canes are grown in 2 seasons. The ones grown from January to April are called spring-planted canes, and the ones from July to October are autumn-planted canes. Currently, the harvesting, which spans from December to April of the next year, mainly relies on mechanical harvesting and partially on manual harvesting. Fresh harvests must be delivered to sugar factories in a timely manner to ensure sugar quality. Sugar canes delivered to sugar factories must be weighed and sampled for quality examination and management before they go into the sugar production process. The production of golden sugar is carried out in 7 stations: juice extraction, boiler, power generation, clarification, evaporation and concentration, crystallization, centrifugal separation and drying, and packaging. Prior to the juice extraction process, the sugar canes go through the desanding sieve and the rotary sifter to remove sand, leaves, and cane trash, which will then be delivered back to the sugarcane plantations for reuse. A 2-stage cutter cuts the sugar canes into small sections for further processing. Hammers in the shredder shred and pound the sugarcane sections into tiny flat pieces while still retaining their fibers and juice. The sugarcane pieces are then sent to the mills. There are 4 mills in a tandem. Each consists of 3 roll shells which roll against the sugarcane pieces to squeeze out their juice. No water is added in the first mill, and the juice extracted here is called the first pressed juice. The second mill is added with the third pressed juice. The third mill is added with the fourth pressed juice. During the fourth pressing, hot water of 50 to 60 degrees Celsius is added to extract as much sugar content as possible. The mixed juice from all the 4 mills then enters the clarification station. The operation of TSC's sugar factories is an epitome of circular economy. Most of the bagasse from the mills is used to fuel the boilers, which generate high-pressure steam to drive the turbines or directly drive mechanical equipment in the factory. The turbines drive the generators to supply 80 to 90% of electricity during the period of sugar manufacturing. The remaining bagasse will be delivered to compost plants to be made into organic fertilizers or reused for other purposes. After powering the turbines, the high-pressure steam turns into low-pressure steam, which can be used as a heat source for heating, concentrating, crystallizing, and boiling the juice. This type of energy utilization is known as cogeneration. The mixed juice enters the clarification station. After the following procedures: heating, the addition of lime milk, sedimentation, and filtration, the juice will become clean. The mixed juice is heated to 101 to 105 degrees Celsius in 3 stages, then added with food-grade calcium oxide. With the pH adjusted to between 7.6 and 7.8, the juice then enters the clarifier, where the impurities in the juice react with the calcium oxide and form mud. The mud then passes through a vacuum filter where the sucrose in the mud is recovered. After filtration, the residue, known as mud cake, is rich in organic ingredients, will be sent to TSC's plantations as a soil conditioner. The clarified juice exits the clarifier from the top and enters quintuple effect evaporators to be concentrated into syrup up to a Brix of 55 to 65. Quintuple effect evaporators are a serial connection of 5 evaporators. The last effect is vacuumed to create vacuum differences among all the 5 effects. Low-pressure steam is added from the first effect as a heat source. The vapor from the juice in each effect is used as a heat source for the succeeding effect. Concentration is carried out simultaneously in each effect. This system allows the use of one portion of steam to evaporate 5 times as much water, thus reducing the use of steam and achieving energy saving. Water continues to be evaporated after the syrup enters the vacuum pan. When the concentration reaches the desired value, fine-grained sugar seeds are added. The sugar seeds absorb the sucrose and grow into crystals of a required size, and the syrup becomes a semi-product called mascuite. The sugar boiling process is completed at this point. Consisting of sugar crystals and molasses, the mascuite is sent to the centrifugal separator. Acting like a dehydration tank, it separates the crystals and the molasses through a high-speed centrifugal force. The crystals separated from the molasses are called raw sugar. The multiple boiling of syrup produces the so-called final molasses. Although not useful in the production of sugar, molasses is an important byproduct and can be used as a raw material for MSG, alcohol, yeast, and animal feed. The raw sugar separated from the molasses is then dried and sieved before being packaged. Currently, only Shanghua and Huwei sugar factories are still in operation in Taiwan. They harvest about 500,000 tons of sugar canes and produce over 40,000 tons of golden sugar. In addition to golden sugar, Xiaogang and Daling sugar factories also produce refined sugar and secondary processed sugar to meet the demand of the domestic market. Using imported raw sugar as raw materials, Xiaogang Sugar Factory mainly produces refined white sugar, refined fine granulated sugar, refined golden sugar, liquid sugar, invert liquid sugar, etc. The annual yield is about 300,000 tons, making up 50% of the sugar consumption in Taiwan. Using products and byproducts from other factories as raw materials, Daling Sugar Factory produces secondary processed sugar such as rock sugar, dark brown sugar, ginger tea, TSC molasses, etc. It also provides small packages of refined golden sugar, Taiwan golden sugar 600 grams, refined white sugar, refined fine granulated sugar, etc. TSC's products all conform to the food health and safety regulations of the Ministry of Health and Welfare. They have also been honored with a certification on ISO 9001, ISO 22000, and HACCP. It has always been TSC's motto to provide safe and quality sugar for consumers. Upholding its corporate social responsibilities, TSC always seeks to realize recycling and reusing. The bagasse is used to fuel boilers to produce high-pressure steam, which is then used to generate electricity and low-pressure steam. The low-pressure steam serves as a heat source for the process. The condensate from evaporation is used for the process as well as in the boilers. This model of water cycle allows about 70% of the water content in sugar canes to be recycled and reused, thus achieving water and energy saving. The ash from the boilers is rinsed with water and stored in the sedimentation basin. The ash is then delivered back to TSC's plantations for reuse. The rinsing water is also recycled and reused. Rich in organic ingredients, the cake can be used in TSC's plantations. It can reduce the use of chemical fertilizers and is an example of how waste can turn into a resource. The remaining bagasse from boilers can be used for a variety of purposes. The mixture of bagasse and molasses, after fermentation, can be made into organic fertilizers. The bagasse can also be made into high-density composite materials such as plywood, paper pulp, the eco-friendly bagasse straw that has become popular recently, etc. TSC has reached the goal of zero waste by recycling and reusing ash, cake, cane trash, and bagasse, which also best exemplifies TSC's effort to practice circular economy. Adhering to its century-old pragmatic corporate spirit, TSC makes full use of sugar canes. The byproducts from the sugar production are all properly reused for the peaceful coexistence between humans and nature. By holding on to its initial aspiration of protecting the environment, TSC continues to pursue circular economy and sustainable development.